Lesson 49, graphing inequalities with one variable. I'm going to use this to quickly grab another bite of my lunch and then start talking to you guys. Okay, September 25th in the year 2000. This is at a very depressing thought because I realized that is this slide available anywhere? Not yet, because I haven't put it online yet, but I can put it on after I finish going through it. Sorry. Yeah, cool. It will be on YouTube eventually later, but I will tell you, I am putting these on YouTube as well, but it's just taking me a little bit of time to get on there. So yeah, so yeah, so I was quite depressed because I just realized that unfortunately for you, this happened probably before you guys were born, which I'm like, holy crap, that makes me feel old because I can remember this happening. But yeah, September 25th in the year 2000, 112,000 people watched the Sydney Olympic track events. And in that track events, an Indigenous female runner, Kathy Freeman, ran the 400-meter final in 49.11 seconds. I think she won at the time. Actually, I don't think she won the world record at the time, but I think she at least won gold in the Olympics, which is massively impressive. I was, it was pretty like she was wearing a lycra like suit, and there was actually a fair bit of controversy at the time because people were like, oh man, I'm not sure if that's cheating. Are you allowed to wear lycra? Because she was wearing it because it was like low resistance and stuff like that. I think she's not the first, wasn't the first Aboriginal Indigenous person, First Nation person to win a gold medal, I think, at the Olympics, but she was at least the very first person to win it for the track. And even then, even if she wasn't, she lit the torch. She lit the Olympic torch at the relay. We were like, as a nation, it was very much coming to the point where we were like, yeah, go Indigenous people. And the fact that we won one of the most watched events with an Indigenous person was pretty incredible. So yeah, and she's retired from track events. Obviously, that was 20 years ago. Oh crap, man, I feel so old. Anyway, that was 20 years ago, but yeah, she still does a lot of humanitarian stuff, which is really good, and like encouraging young runners too. So let's get to today's lesson. Graphing inequalities with one variable. So we'll be able to sketch linear inequalities. So let's jump back and talk about what we did last time. Last time on Friday, I gave you guys a quick lesson on this. And what we did in that quick lesson is we talked about, firstly, the vocabulary, which is these are the signs here that we're going to be using a lot. And then I brought up this old, grade 6 level like poster that I still use. As I said to you guys, I still remember, the bigger number, crocodile eats the bigger number. That's how I do a lot of this maths. It's kind of like juvenile, but if it works, it sticks in your head, then it works. We did an example here, and then we did our very first picture example. And I showed you the idea about solid circles versus unsolid circles. For this one, we eventually broke it down, and then we did a solid circle and we moved forward. I want to actually continue that. We didn't do this one. Yeah, we didn't do this one. I think we did this one, but we didn't do this one. So maybe let's quickly do this one before we move on to today's lesson, which is pretty much the same thing anyway. I want you guys to write down this equation here. -3 is 2x plus 1 is greater than -3, but less than 7. So I want you to write this down, and we're going to simplify it in a sec. Okay, so this plus 1 here, this plus 1 just means that, you know, if 2x has to be less, 2x plus 1 has to be less than 7, then 2x must be less than 6, because I have to add 1 to it anyway. So what we're going to do is we're going to do the same thing we would normally do. We're going to cancel out this 1. Actually, I'm going to do this in a different color. We're going to cancel out this 1. I'm going to subtract 1 from both sides. So that's going to give us, and again, remember, don't have a pen here, so I'm just trying to do this with a, it's very, very, very awkward. Oh my God, is less 2x, which is less than 6. Okay. So both of these still give the same, are still just as true as each other. And then the next one would be like, for example, if you take 1, 2 times 1 is 2 plus 1 is 3. 3 is more than -3. 3 is less than 7. If you still substitute 1 in here, 2 is less than 6. 2 is more than -4. Now, if you divide everything in this by 2, again, you can do that because it's pretty much the same as how you would do regular equations. Divide both sides by -2, which is going to, by 2, sorry, not -2, my bad. That's going to give you -2 is less than, x is greater than -2, but less than 6 divided by 2 is 3. So as long as I choose a number between -2 and 3, all 3 of these will work. So let's choose a number. Let's choose 0. 0 is between -2 and 3. So 2 times 0 is 0, plus 1 is 1. 1 is more than -3, but less than 7. Now, how do you plot this on this graph? Well, remember, this doesn't include the values, so we use open circles. That means at -2, I put an open circle here. Pretend that's a circle. And then at 3, I do another open circle, because see how both of these don't say including those values. And then I draw a line that connects those two together, like a straight line. This is so straight. Oh my God, I made it. Okay, so what, like for example, let's substitute 3 in here. If I put 3 in here and let x equal 3, what I end up with is 2 times 3 is 6 plus 1 is 7. We end up with this problem. 7 is less than 7, and that's not true. 7 is not less than 7. That can't work. So therefore, we have to make sure 3, that's an open circle. It can't be 3 and it can't be -2. So that's how we represent inequalities on a single line. We call these one-dimensional inequalities because they only have one, or one variable inequality, sorry, because they only have one variable. That variable is x. It's the only thing that they use as their variable. Okay. So I'm going to change the slide now. If you guys haven't copied this down, which I would have suggested that you should have been copying it down as I went. Yeah, I'm going to change the slide. I'm going to grab a bite of lunch and then I'm going to change the slide. Okay, so next up is to take this to the next level. So I'm going to show you guys this actually first. I want to show you guys this here. This is similar, but actually a bit different. I'm going to plot this graph. I'm going to plot this for you. But first, can I get you to copy this down? And then I'm going to get you guys to copy down these two equations, because I'm going to draw them and you won't be able to see this after I start to copy down. So just copy these down and then I'll sketch it. Okay, I'm going to assume you guys copy this down. This is actually a oh wait, sorry, someone said wait, it's fine. This is actually a flashback to piecewise graphs. Now, that was one of the other things they said, is that they're looking at changing one of the questions on the test to include a question like this with piecewise graphs. So I thought, well, I better show you guys what we mean by that. And because this ties in with what we just did, I feel like this is a perfect place to put it. Oh, you guys can see me eating noodles? How can you see me eating noodles on the... Oh, I see what you're doing. I thought... Oh, you guys can see the... Oh, well, whatever. It doesn't matter. They're good noodles, so deal with it. I'm just jealous because you can't have noodles. All right. So... let's give this a try. So what we're going to do is I'm going to plot that graph into this. So what we're going to do is we're going to plot two graphs. The two graphs are y equals x plus 1, where x is less than 4, and y equals negative a half x plus 10, where x is greater than 4, greater than or equal to 4. Now, this is exactly the same way that you would do a piecewise graph normally, except in this case we have a bit of an issue, a bit something that you wouldn't encounter in the previous topic. Let me show you. And as I go, I would strongly suggest you guys to copy this down as I go. So I'm going to draw in a quick little... How big do I want it? Make it 8 centimeters. Obviously, I'm going to make it bigger than what you guys would make it, but I want you to... The reason I'm making it bigger is so that you guys can see it. But you should try your best to make an image big enough that you can sort of see it. We're only going to do the first quadrant, so I'm only going to do these 2 points here. I'm going to drop some points on the bottom here. So we go 1, 2, 3, 4, 5, 6, 7. The vertical axis 1, 2, 3, 4, 5, 6, 7. Cool. Okay. So we're going to plot these two graphs. The first one we're going to plot is we're going to plot x plus 1. We're going to plot that all the way up to 4. So what does that look like? Well, the y-intercept of this is 1. So therefore I'm going to put a point at 1. The gradient is 1 over 1. So m equals 1 over 1, which means we've got a rise of 1, a run of 1. So that means we're going to go across 1 and up 1. And I've got 2 points. I'm going to continue this line all the way up until I hit this other line. So And that's exactly how you would normally draw a piecewise graph. This point here, by the way, if I substitute x equals 4 into that, y equals 4 plus 1 is going to be 5. So that point here is at 4, 5. Now, the next part of this is to plot this graph here. But there's a bit of a catch with this one. Okay? For this one, we're not going to start over on the left here. We're not going to use 10 as our y-intercept. I'm going to use 4 as my first point. So how do I do that? I'm going to substitute that in. Y equals -1/2 times 4 plus 10. -1/2 times 4 is going to be -2 plus 10, which is going to be -8. Okay. Now -8 is actually all the way up 5, 6, 7, 8. It's all the way up here. So this is our first value, and then we've got a gradient of -1/2. What that means is that m equals -1/2, which means we've got a rise of -1. We've got a run of 2. So that means I'm going to go from 8. I'm going to go down to 7, but I'm going to go down 1, but I'm going to run 2. So 1, 2. So it gives me a point about there. And so that gives me this line that looks like this. Now, here's our problem here, right? Normally, these in a piecewise graph, normally you would expect these two to be joined. But in this case, they're not joined. So the question becomes, okay, well then what is at 4, what is the value? Is the value 4, 8? Or is the value 4, 5? Which one is it? The answer is it's greater than or equal to 4 for the second one. So this one here is what the value of 4 is. At 4, when x equals 4, the y value is 8. So to signify that, I use a closed circle here. Just like how I used a closed circle before. When I want to include 4, 5, I use a closed circle. However, with point 4 on the other graph, because 4, 5 isn't included because it's less than 4, not less than or equal to 4, this point here is not included. So I use an open circle here to signify that it doesn't include this point, it doesn't include this point. The other things I've used just to make things clear here is I put an arrow here and an arrow here. The arrows indicate that this graph continues and it doesn't terminate. And the reason is that it does terminate at this end is it continues on at this end. It doesn't terminate in this end. It does terminate at this end, it just doesn't include that. But it does continue on past this point here. So that is another piecewise graph. The only difference between this and the graphs that we talked about before is that we've got a solid circle here to give and an open circle here to help us tell which of those two is included or not included. Just like how when we use greater than or equal to, it's the same idea. All right, guys, I'm going to give you guys a sec to copy that down. I'm going to grab another bite of my noodles, and then I'm going to continue with the lesson.
So could you move the paper a bit to see the other numbers? Yeah, thank you.
So these were just my calculations. This is my gradient, and this was down here was the substitution of 4, so I could figure out where this point was. If I'd have done my axes a bit larger, I could have actually used the y-intercept and just done a dotted line, and then when I got to that 4, then do a solid line. But I don't know, I like this a bit better. I think it's a bit neater. Oops, sorry. Okay, let's jump into the rest of it. I can put this back up later on if someone needs it. Just give me a yell out, but we're going to keep going on with the rest of the lesson. So, okay, so next up, representing inequalities in 2 dimensions. This is not much different, but yeah, I wanted to show you guys just the basics. And this is, we're still only using one variable, okay? We're still just using x, okay? We're not using x and y at the moment, we're just using x. So what we're going to do is we're going to represent when x is greater than -3 but less than 1. So x is greater than -3 but x is less than 1. To do that, what we're going to do is we're going to say, and we're going to note that this is less than or equal to. So how do we do that? Well, we're going to do 2 points on our graph. We're going to do a point here at -3, which is going to be an open circle. And then we're going to do a point here at 1, which is going to be an open circle. And the value of x can be any one of these values as long as it's between those 2 points. So I'd like you to copy this down here. Okay, I'm about to change the slide in about a minute, so I'll give you guys a minute to copy it down, but or maybe less than a minute, maybe like 30 seconds, but the next slide is only a little bit more different. Okay. So this is still 1 dimension though. Where is our 2 dimensions? Our 2 dimensions shows up like this. I can extend each of these lines up, right? And I still know that the important area, oopsies, I still know that the important area is between this point here and this point here. Because there's -3 and there's 1. That's still the important area, even though now I've got all these extra y variables. So all I need to do now is when I add, I need to add, instead of adding points to represent the end at -3 and 1, I now need to draw a line at -3. Now, one very, very important thing to note here, because it's going to be the difference between you getting sometimes full marks and getting no marks at all, is this. Notice that the line here is a dotted line. Okay? That is on purpose. Okay? The dotted line helps us understand, okay, well, that means that this is a, the dotted line helps us understand that this is not included. Okay, it's like the open circle, but instead of doing an open circle, we do a dotted line saying, well, it's not a solid line, so it doesn't count. As for the other side, though, we also need to have one here at 1. So we know that, and the last part's going to be this. We want to make sure that this region in the middle is the region that we know that counts. Now, I'm going to ask you guys, I'm going to have to double check this with the textbook, with the test, with everything, because it changes from place to place. But if we want to make sure this middle part is the part that is selected, what we can do is we can shade the other two areas. Now, when you guys do shading, what it will probably look like will be just like a line. So you might have something that looks like this. Like that to shade, or you can use a highlighter or something to shade, but as long as it's shaded. So when you guys draw this diagram now into your book, the reason I'm trying to be very careful here is because sometimes you want to shade the region that you want. You want to shade the inner region. Sometimes you want to shade the regions that you don't want. And it depends on the question. So it's actually really important for you to read the question. So just going to give you guys a minute to copy this down as a two-dimensional thing. Obviously, this is a bit, if we were just looking at when x is less than, when x is greater than -3, there would only be one line. In this case, there are two lines. But most of the questions you're going to be doing are going to have just one line. So now this is in 2 dimensions, but it's still just one variable. Now I'm not going to do 2 variables today. I think that might be asking too much. And I feel like I'm going to give you guys a chance to sort of start working on chapter 12. So yeah, that's why I don't want to do too much of it at once. But believe it or not, that's actually it, I believe, because I think the next slide is, yeah, cool. So what I'd like you guys to do now is I'd like you to work on 12A, 12B, and 12C.